Hi everyone. In this video, we're going to be doing A-level maths 9231, paper 33, further mechanics, major in 2025. This paper is 1 hour 30 minutes long, so we'll try to finish within that time limit. So without further ado, let's head on to the first question. Okay, so for this first question, we're told that a particle P of mass m is attached to one end of a light insensible string of length A. And we're told that the other end of the string is attached to a fixed point O. So all this will help us in making our diagram later on, which will help us to solve this question. Okay, and then what else it says? Okay, the particle moves in a horizontal circle with constant angular speed omega and with the string inclined at an angle theta to the downward vertical. And we're also told the tangent theta is 4/3. We have to find omega in terms of A and G. Okay, so first of all, let's sketch the diagram. So this is our downward vertical, and this is the string. So this would be the angle theta. And let's say the particle P is here. So this is O, and then this is P. Oh, and then this is length A. And then since it is mass M, the weight acting on it would be mg, because W equals to mg. Yeah, that's all they told us in the O. And the angular speed is omega. Yeah, so that's all they said in the question. And yeah, now let's label all the remaining forces. So obviously, since it's a string, there has to be tension acting in this direction, right? Yeah, these are all the forces. Now we can find omega. So first of all, let's take all the vertical forces. So we got the weight. So that's the vertical component of the tension, which is T cos theta. And for circular motion, since only the horizontal velocity is changing, like the direction is changing, the centripetal acceleration is only acting towards the center of the circle in the horizontal plane. So the vertical forces, they must be in equilibrium. So let's equate those. Okay. Okay, yeah, so this is our equation one. Now let's find our centripetal force. So centripetal force is the force that's acting towards the center of the circle, like as a force acting on the particle that is acting towards the center of the circle formed by the object. So from our diagram, we can see that it's only made up of the horizontal component of the tension. So this is just T sine theta. So using our force formula, F equals ma, and substituting our centripetal acceleration formula, A equals r omega square, we get F equals m r omega square. So F is the, what you call, the centripetal force. So this is going to be T sine theta. Then m is the mass, that's just m. And r, well, r is the distance from the center to the circle formed, so the distance from center to P. So we can easily find this out using simple trig because this is a right angle triangle. This would just be A sine theta. Okay, so A sine theta omega squared. Okay, so we can see the sine thetas cancel out. Okay, so we only have T equals to ma omega squared. Okay, so this is our second equation. So these are the two equations we found. And as we can see, the second equation is in terms of T. So I'm going to substitute into the first equation. So we're going to sub 2 into 1. So T cosine theta would now just be MA omega square cos theta equals to mg. So the m cancels out. We have to find omega, so let's make omega the subject. So omega equals to uh, g over a cosine theta. So we have G and A. Now we just need to know cosine theta. And luckily for us, they gave us what tangent theta is. So you can either just type it into calculator or, sketch the right angle triangle. You'll get theta, the opposite would be 4, adjacent side would be 3, so hypotenuse is 5. So cosine theta is just 3 over 5. So this is going to be 5 over 3 GA. Okay? Yeah. And then just take the square root on both sides. You will get 5G over 3A square rooted. So this is our final answer for the first question. Let's head on to the next question. Okay, so for the second question, we are told that a particle P of mass m is attached to one end of a light elastic string. So that means when the string is extended, there would be elastic potential energy, but when it's compressed, it's not going to have any EPE of natural length A and modulus of elasticity mg. The other end of the string is attached to a fixed point O on a rough plane. Okay, so that means particle P will be experiencing frictional force inclined at an angle 30 degrees to the horizontal. Okay, and then it tells us the particle P is held at rest at point O before being released. Okay, the frictional force acting on P as it slides down the plane is 11 over 30 mg. So these are all the information we're given. Okay, so for the first part, we need to find, in terms of A, the distance that P moves down the plane before coming to rest. Okay, so the way we do this question, let's first draw a diagram of the whole setup. So it's an inclined plane, inclined at 30 degrees to horizontal. We'll let this point be O, okay, and then what else? It's a rough plane. Okay, we'll let P be this. We'll let P be equals to this. Okay. And then obviously the string. Okay. All right. Okay. So for this question, it's best to use the energy method. So we're going to find the energy up here at O and the total energy when it comes to rest down here. Okay, so we're going to let the distance traveled be x. Okay. Yeah. Okay, so let's start. So initially at O, the string is not stretched. It's not moving because it's held at rest. So the only energy there would be GPE. So let's find the GP. So let's use MGH. So your H would actually be the vertical distance. So using simple trick, you can easily figure it out to be x sine 30 degrees. So sine 30 degrees, 6 That's just half, so you get half mgx. So this is the initial energy at O. Now let's find the total energy at P. So finally at P, since it came to rest at that point, there's no KE. There is obviously no GPE because we are measuring the GPE relative to this final position. So the only energy that we'll have is the work done against frictional force as well as elastic potential energy. Because so you guys have to know about this frictional force. Like the GPE initially, the energy that energy is also used to do work against the frictional force as well as convert to the other forms of energy, which like EPE. Okay, so let's find the work done against frictional force. I'm just going to write friction here. So yeah, just use your F times D formula. So that's just 11 over 30 and G, distance from this X. Okay, now let's find our EPE. So to find your EPE, you have to use the formula from your MF19, sorry, under for the mechanics section. So you have to look under elastic strings and springs. You look at the formula where the subject is E. So this means energy, like elastic potential energy. So it's lambda x squared over 2L. So let's write that down. So lambda is our modulus of elasticity, which is mg. X is the extension, not the x we have defined. So that's going to be x because that's the total length of the string at our final point, and minus the natural length, which is a. So a squared over 2L. L is the natural length, so it's just 2a. Okay, now we can finally equate these. So let's add up all the final energies. So 11 over 30 mgx plus mgx minus a squared over 2a. So we're using conservation of energy here, okay? Where we have to know that the total initial energy is equals to the total final energy. No energy is lost. Yeah. So this is the final equation. Let's try to factor out some common terms. Okay, so I can see that we can factor out 1 over 30 mg. So you'll get times 11x times 15 x minus a squared over a. Okay. Yeah, and then this is equals to 11 over 30 mg 15x. Yeah, so we can cancel these out, and this would be our final equation. So let's expand out the x minus a squared as well. So we can use a minus b squared identity, which gives us a squared minus 2ab plus b squared. So that's a squared minus 2ax plus a squared over a. That's equals to 15x. Okay, now let's multiply both sides by a to get rid of the denominator. So we get 11ax plus 15 times x squared. Let's also expand the numerator. So this gives us 15x squared. 15 times minus 2ax, that's minus 30ax. 15 times a squared, that's plus 15a squared. Let's also move the 15 over to the left-hand side. So minus 15x equals to 0. Okay, now let's group all the terms together in terms of their x power. So the x squares go together, the x terms go together. So we have 11ax minus 30ax minus 15x. So this gives you minus 30 plus 11, that is minus 19ax minus 15x. And then the only constant term we have is plus 15a squared equals to 0. Okay, let's see if there's any errors. See if I made any errors. Nope. Okay. All right, now we'll go to group all the terms up clearly. So 15 minus 19a times x plus 15a squared equals to 0. Okay, now we're going to solve this quadratic equation. As you can see, it's a quadratic equation, so we're going to solve it using a quadratic formula. I think I might have made a mistake. Oh, yeah. Sorry, everyone. Oh wait, not here. Yeah, so this is supposed to be 15ax. Yeah, so this is minus 15ax. So let me just erase this. So the final answer is supposed to be minus 34ax. Okay, so b is minus 34a. So b squared is minus 34a squared. Wait, no, minus b, sorry. So just 34a plus minus b squared, which is minus 34a squared, minus 4 times a, which is 15, and c, 15a squared, or 2 times 15. Now we're ready to solve it. Just type all the terms you can. Like evaluate the square root in your calculator. So minus 34 squared minus 14 times 15 times 15. You get square root 256. So that gives you 16a. And 34a plus 16a is 58. 58 divided by 2 divided by 15, you get 5 over 3a. As for the other solution, you get 34 minus square root 256, 18. 18 divided by 2 divided by 15, you get 3 over 5a. So which answer do we reject? So here we assumed that the string has extended, okay? So that means ax has to be more than a. So we're going to reject this. And hence, we can conclude this as our final answer, x equals to 5 over 3a. Let's head on to the next part. Okay, so now we're told that P remains at rest in this new position. So that means P is in equilibrium, so both the horizontal and the vertical forces are balanced as well. So we now have to find, in terms of m and g, the magnitude of the frictional force in this position. Okay, so all right, let's just draw another diagram. Okay, so this is 30 degrees, and then, okay, we draw P in here. So let's label all the forces acting on P. So first things first, obviously, since P has mass, there is weight acting on it. So that is just mg. Since there is a string connected to P, there is tension acting on the string that is connected to P. I'm going to assume that it's acting here. Okay. And then obviously we got the normal contact force acting perpendicular to the plane. And lastly, we can say the frictional force is acting here. So what I recommend you to do is to not worry about the direction of the forces that you label, because if your direction is wrong, you're going to get a negative value for your force, okay? And if you do get a negative value, you will immediately know that your direction was wrong, okay? So don't worry about that at first. All right, so let's label the vertical forces. So the vertical force, we have N, and as well as the vertical component of the weight, which is here. So that is, angle here is 30 degrees, so that's just mg cos 30. So we can equate these two forces together to give us N equals to mg cosine 30 degrees. So cosine 30 degrees, sorry, you get square root 3 over 2 mg. Yep. Okay. As well as for the horizontal forces, um, apart from the friction and the tension, we also have the horizontal component of the weight right here. So this is going to be mg sine 30 degrees. So we're going to equate F plus mg sine 30 degrees, since they're in the same direction, equal to tension. Okay. All right. So as we know, F is equals to mu n, where n is the normal contact force. Sine 30 is half, so half mg. And then T is, we actually worked it out here. Oh, never mind, we didn't. Okay, that's just lambda. Okay, can refer back to here. So look at this formula. This is the formula for tension in elastic string when it's stretched. So it's just lambda x over L. So lambda is the modulus of elasticity. So that is mg. And then x is just the extension. So we know our total length is 5 over 3a. So 5 over 3a minus a, no, minus 1 times a. And that is over 2a. Oh, wait, no, just a, because it's just over L. So the a's cancel out. Okay. And then as for mu, let's see. Oh, never mind. It didn't give us the coefficient of friction. So we're just gonna solve for F then, I guess. Yeah, I don't think we should have solved this. This was completely unnecessary. Yep. All right. So F is equals to 5 minus 1, that is 2 over 3 mg minus half mg. And I'm sure I'm gonna get a negative answer. Well, never mind. So I got 1 over 6 mg. So this means our direction that we initially assumed is correct. Okay, so this is our final answer for this second part, as well as the entire question. Let's head on to the next question. Okay, so for this question, we are told that a ball of mass mkg is projected vertically upwards with initial speed u meters per second and moves under gravity. So the only force acting on the ball is its own weight. And then we're also told that at time t seconds after projection, the ball has traveled a distance of x meters and its speed is v meters. Oh, and then we're also told that there's a resistive force of magnitude mkv squared newtons, where k is a positive constant. All right, so for the first part, we have to show that the distance traveled by the ball when it's moving upwards is x equals to this. Okay, so in order to do this, we're first going to write down Newton's second law, F equals to ma. Okay, and for F, that's the resultant force acting. So since the ball is moving upwards, we're going to take any upward force to be positive. However, both of our forces, both the weight and the resistive force, they're acting downwards. So we're just going to take minus mg minus mkv squared equals to m. And for A, we can actually use the fact that A is equals to dv dt. And then we can use our chain rule to re-express this as dv dx times dx dt. And dx dt, that is just v. So this is just v times dv over dx. So this is mv dv dx. Okay, so we can cancel the m out, just remove it. So that's just minus g minus kv squared equals to v dv over dx. Okay, so now we have a differential equation that we can separate. So let's bring all the v terms to the right-hand side and move the dx to the left-hand side. So we get dx equals to v over minus g minus kv squared dv. So we integrate these with respect to each other. Okay, so 1 dx, you will just get x, and then this is plus c equals to, okay, so for this type of function, like I said in my previous videos, check if the magnitude of the numerator is 1 degree less than that of the denominator. So in this case, it is. The denominator's degrees 2 and the numerator's degrees 1, right? So we're going to express it in this form, f prime x over fx. When you integrate it, you'll get ln fx. So fx in this case is minus g minus kv squared. So when you differentiate it, you will get minus 2kv. So this is now in the form of f prime x over fx. And to make this into the original form, we're going to multiply this by 1 over minus 2k. Yeah, so now we can integrate. This is minus 1 over 2k times ln minus g minus kv squared. Okay, don't forget to put the modulus sign because this is clearly going to be negative. All right, now to find c, we're going to make use of this fact, the initial speed in meters per second. And obviously by common sense, you should know that when the initial speed is u meters per second, the distance traveled is 0. So we're going to sub x equals to 0 and v equals to u. So x 0 plus c, that's just c, and you get 1 minus 2k ln minus g minus k u squared. Okay. So hence, final equation is x minus 1 over 2k ln minus g minus k squared equals to minus 1 over 2k ln minus g minus k squared. Okay, so now let's just make x a subject. So add this to both sides. You'll get 1 over 2k ln minus g minus k u squared minus 1 over 2k ln minus g minus k v squared. So let's factor out 1 over 2k. Okay, so this is ln minus g minus k u squared minus ln modulus of minus g minus k v squared. So for this one, we can use the log laws. So ln a minus ln b, we'll get ln a over. So final answer, just be 1 over 2k ln minus g minus k u squared over minus g minus k v squared. And we can factor out -1 from both the numerator and denominator, which will give us our final answer of 1 over 2k ln modulus of g plus k u squared over g plus k v squared. Yep, that is our required answer. So this is our final answer for the first part of this question. And since they already gave you the result, you should write shown at the bottom. So with that, let's head on to the next part. Okay, so now we are told the values of k. So k is equals to 0.025 and u is equals to 20. So for this part, we're supposed to find the time taken for the ball to reach its maximum height. Okay, so for this question, since we don't know what the ball's maximum height is, we're going to make use of the fact that when the ball reaches the maximum height, v is equals to 0. So for this question, we're going to have a function, we're going to have to express v in terms of t, right? So let's take our f equals ma. Okay, so f is just minus mg minus mkv squared, and a is just equals to dv dt. Now we'll divide m on both sides. You will get minus g minus k v squared equals to dv t. Okay, and now we're going to separate the variables. So we'll move the dt over to the left-hand side. So again, dt equals to 1 over minus g minus k v squared dv. We have a differential equation and we separated it. Now we're going to integrate both sides. Okay. So for the left-hand side, we're just integrating 1 with respect to t. So that will just give us t plus c. As for the right-hand side, the first step that we can do is to factor out -1 from the denominator. So you take that -1 out of the integral, you get minus integral of 1 over g plus k v squared dv. Okay. Oh, yeah, let's also substitute 0.025. So you get 1 over 0.025 v squared plus g dv. Okay. And to make this even simpler, since I prefer like whole numbers, I'm going to multiply both the numerator and the denominator by the denominator of 0.025, which is 40. So you can get 40 over v squared plus Okay, we can just take G as 10, so 40 times 10, that's 400 dV. And we can take the 40 out. So you will get minus 40 integral of 1 over V squared plus, uh, let's express 400 as 20 squared. So the reason we did this is because for any rational function, where the denominator is quadratic that you cannot factorize and the numerator is a whole number or a constant, you are going to have to express your integral. Sorry, you're going to have to express your integral in this form. I will highlight it right here. 1 over x squared plus a squared. You integrate, you get 1 over a tangent inverse x over a. So the final integral would be 1 over 20 tangent inverse v over 20. Okay, so simplifying everything, you get t plus c equals to minus 40 divided by 20, you get minus 2 tangent inverse v over 20. Okay. Okay, so now to find c, we're again going to make use of this fact. Okay, so we're going to sub t equals to 0 and v equals to u. So u is now 20. Yeah, so we'll get minus 2 tangent inverse 20 over 20, that's 1, equals to t plus c, which is 0 plus c, so you get c, and then c would just be, okay, it's better for us to express this in terms of radians. So that is minus pi, minus 2 times pi over 4, you get minus pi over 2. Hence, we'll get t minus pi over 2 equals to minus 2 tangent inverse v over 20. Okay, and now we're going to sub v equals to 0 because that's the speed of the ball when it reaches its maximum height. So you get minus 2 tangent inverse 0 divided by 20. So you just get 0 equals to t minus pi over 2. You get t equals to minus 2 times tangent inverse 0, you get 0 plus pi over 2. You just get pi over 2 seconds. Yeah, so this is our final answer for the second part, as well as the entire question, per 2 seconds. Let's head on to the next question. Okay, so for this question, we're told that an object consists of a uniform lamina with a particle attached. Uniform lamina ABCDF of mass M is formed from rectangle ABCD, so you can see right here an isosceles triangle CEF. So that means CE and FE, the lengths are equal, where F is the midpoint of CV. Okay. Okay, the rectangle has sides AB, 2A, and AB equals to A. It's all on the diagram. Triangle CF has a base A. Yep, so diagram and height 2A. The particle of mass Km is attached to the lamina at E. So is this particle right here. So since its mass is Km, its weight is Kmg. The object sits in a vertical plane with its edge AD on the horizontal ground. Yeah. Okay, so now we're told that given the object is on the point of toppling in its vertical plane about the vertex D, so that means this object it's going to topple like this. So this is the point D. It's gonna go like this or like this, but I think this makes sense, okay? Yeah, so it's going to go clockwise, yeah? So since it's on the point of toppling, they're just saying that it's in equilibrium, right? So that means the moments are balanced. So we have to find the value of K. Okay, so as I said earlier, we have to find the value. We have to we have to find the moments acting on this. So let's first find the forces acting on this. So the only forces we have are the weight of the lamina, mg, as well as the weight of the particle, right? So we just have these two forces acting and nothing else because they did not say whether the whether the ground was horizontal, rough or smooth. So we're just gonna assume it's smooth, okay? Yeah. So, but then to find moments, we also have to know the distance about the pivot, and in our case, the pivot is the point D. So I have to know the perpendicular distance. So you have to know this as well as this. Okay, we already know for that this is 2a. So now we're going to find this missing distance. So to do that, we're going to find the center of mass, like the distance of the center of mass, the horizontal distance from the edge CD. Okay, so to find the center of mass, you have to make a table like this. So in this column, you write down the shapes that form your lamina. So we have ABCD, ABCD, that's the rectangle. And then we have the triangle CEF, and then finally the lamina. So first we're going to find the area of each of the individual shapes and add them up to get the area of the lamina. So for ABCD, it's just a rectangle, so it's just 2a times a. You'll get 2a squared. And for CEF, it's a triangle, so you take your base times the height, so half times base a times height, 2a. So you get the 2's cancel out, you just get a squared. So CEF is a squared. So lamina is just 2a squared plus a squared, you get 3a squared. Okay, and now we are ready to find the center of mass for each of the individual shapes first. Okay, so I'm just gonna say COM from D, the horizontal distance. Okay, so for ABCD, obviously it's going to be in the center of the rectangle. So the horizontal distance would just be halfway from here to here. So that's just A over 2 for the rectangle. As for the triangle, it's a bit more complicated. Okay, so to find the distance, to find the center of mass of a triangle, we're going to first take the x coordinates of the vertexes, the vertices, right? Like the horizontal distance. So for C and F, since it's lying on the edge, this would just be 0 and 0. And then for E, since it is 2a away, so this is just going to be 2a. So to find that, just add up the coordinates of all your vertices, divide by 3, you'll get 2 over 3a. So this is the distance of the center of mass of the triangle from edge CD. And then for the lamina, we don't know, so we're just gonna write x bar, okay? Oh, shoot, sorry. Yeah, cancel. Okay, now we're gonna take moments about D, okay? So taking moments about D, we're just gonna take the moment of the ABCD and CF and we'll equate it to the moment of the lamina. So you'll get 2a squared m because it's a uniform lamina. So the mass is directly proportional to its area times the distance a over 2 plus a squared m, 2 over 3a. You'll get 3a squared mx bar. So you'll get two twos cancel out, so you get a cubed m, and okay, 2 over 3 a cubed m. This equals to 3 a square x bar m. So the m's cancel out. 2 over 3 plus 1, that is 5 over 3. Yeah, 5 over 3 a cubed, that is equals to, oh, this m also cancels out, that would give us 3 a square x bar. So the a squares also cancel out. So now you just isolate for x bar, you'll get 5, sorry. Oh, okay, so you get 5 over 3 uh, a times 1/3. You get 5 over 9a. Yeah, so this is the distance of the center of mass of the lamina from this edge. So this is going to be 5 over 9a. So now we're ready to take moments about the vertex D. Okay, so let's form the equation here. So this weight is going to cause an anti-clockwise movement. Okay, so the weight times the distance is 5 over 9a. That's equals to this moment. So this moment obviously is gonna make a clockwise moment, right? So this, we're gonna equate it to this one. So kmg times 2a. So we have mga as the common factor, so we can cancel that out. We get 2k equals to 5 over 9. Wait, something's wrong. 5 over 9. Okay. Mm, okay. 5 over 3a squared. 1/3. 5 over 9. Okay, sorry everyone. So one thing I forgot to mention is you have to set this to be your y-axis and this to be your x-axis. So any distance in here would be positive and any distance here would be negative. Or you can also switch around, but you have to be like consistent, okay? So ABCD is actually supposed to be minus A over 2, okay? Yep, nothing else. Okay. Yep, nothing else. So this is minus A over 2. So minus A cubed. So 2/3 minus A cubed. You will get minus 1/3. So minus 1/3. That you'll get minus 1 over 9a. So that means center of mass is here to the left of the y-axis, 1 over 9a from the y-axis. Yeah, so this distance is going to be 1 over 9a. So 2k is equals to 1 over 9a, and then k was to 1 over 8t. Yeah, so this is our final answer for this whole question. And if you don't want to go through like negative or positive, I suggest you set this as your y-axis because there's like nothing over to the left, so everything would be positive. Or you can set this up, but I mean, you can set this up and everything be negative, okay? Yeah, so with that, let's head on to the next question. Okay, so for this question, um, we're told that a hollow cylinder of radius r is fixed with an axis horizontal. So that means this is a vertical circle, okay? And points A, B, and O are in the same vertical plane, perpendicular to the axis of the cylinder, with A and B on the smooth inner surface and O on the axis. So it's the center, okay? OA and OB make angles 90 and alpha respectively with the upward vertical through O. Yeah, so it's given a diagram with A and B on the opposite sides of the vertical. Yeah, it's given the diagram. And the particle of mass m is projected vertically downwards from the point A with this speed and moves in a vertical circle inside the diagram. And lastly, we're told that the particle loses contact with the cylinder at point B. So that means there's no normal contact force at point B here. Okay, so using all this, for the first part, we have to find the value of alpha. Okay, so for any vertical circles question, you are supposed to solve it in terms of energy as well as forces. So first of all, we're going to use our conservation of energy and calculate the energy at both A and B. So let's first calculate the energy at A. So we're gonna calculate the GPE relative to this horizontal line, okay, where A is. So since A is on this line, there is obviously no GPE, so there's only KE. So the KE, okay, is just half. Okay, particle mass is m, so V squared is just 3 over 2 GR. This is equal to the energy at B, the total energy at B. So energy at B is mg, okay, R. So we want to find this vertical height here. So this is R cosine alpha. Yeah, R cosine alpha. And then we obviously have the speed there. We'll just let it be V for now on. So this is half mv squared. Okay, now let's simplify everything. So mgr cosine alpha plus half mv squared is equals to 3 over 4 mgr. So we're not gonna cancel out or factor out any terms. I'm just gonna leave the equation like this. You'll see it later on why I did this. Okay, now we're gonna look at from like a forces point of perspective. Okay, so from at which point should we like consider the forces? So from A, the forces acting are the weight and the normal contact force. However, we don't know the normal contact force. And the normal contact force is the only force that has a component pointing directly towards the center of the circle, which is O. So since we don't know, we're not gonna do it from A. We're gonna do it from B. So at B, since it loses contact, again, there is no normal contact force, which is zero, so we only have the weight acting. And at B, the vertical component of the weight will act as a centripetal force. So this component, so the angle here is alpha, so this is just going to be mg cosine alpha. So we're going to use the formula F equals ma and equate the centripetal acceleration A with v squared over r. So you get F equals to mv squared over r. So force is mg cosine alpha. You will get mv squared over r. And then you can multiply both sides by r to get rid of the denominator. So you'll get mr cosine alpha equals to mv squared. So this is our second equation. And since our question told us to find the value of cosine alpha, we should ideally try to express everything in terms of cosine alpha and nothing else. So we're going to substitute the second equation into the first equation. Okay, right. So we will get second, we get mgr cosine alpha plus half mgr cosine alpha equals to 3 over 4 mgr. So now we're going to factor out mgr and cancel it out. So you just get half cosine alpha plus cosine alpha, you get 3 over 2 cosine alpha. And this is equals to, 3 over 2 cosine alpha, that's equals to 3 over 4. And then cosine alpha, you'll just get 3 over 4 times 2/3, which should give you half. And now you can easily find alpha by taking the cosine inverse on both sides. For this, take your calculator. Okay, just look at the the unit for alpha. Since they gave the right angle as 90 degrees and not pi over 2, we're just gonna express in degrees as well for consistency's sake. So you'll get 60 degrees. So this is a final answer for the first part. Let's head on to the next part. Okay, so for this second part, we have to find in the subsequent motion, we have to find in terms of r the greatest height above or reached by the particle. Okay, so to do this, we know that at B, the particle lost contact, all right? So after that, it would just be it will just be under gravity's influence, so it's going to experience projectile motion. Okay, so first things first, we should do is to find the initial velocity. Again, we'll let it be v, and the angle that is projected from. So to find that out, so this line is tangent to the radius, so it's 90 degrees, and we know this is alpha, so this is 90 minus alpha, and 90 minus 90 minus alpha, you just get alpha. So for this, the angle of projection is alpha, and the initial velocity is v. Okay, since we want to find the greatest height above O, we just need to be concerned with the vertical component of the velocity. So vertical component is just v sine alpha. Okay. We given v. Okay, let's just keep it as v for now. So only given alpha. So v sine 60. That would be equal to square root 3 over 2v. Okay, so that's all we got. All right. Okay, you know what? Let's just find v. So we're going to take the second equation. Okay. Mgr cosine alpha equals to mv squared. Okay, so we get gr cosine alpha equals to v squared. So v squared is just gr cos 60. So cosine 60. Oh my gosh. Okay, that's just half. So you just get half gr. So v is equals to square root half gr. Yeah. Okay. And now we're going to use Subat equation you can find in your MF19. Yeah, we're going to use, let's look for one with S. So we're going to use this because we don't want to trouble ourselves to find the time. All the other equations have time. This one only has the initial and final velocity, as was the acceleration. So we're going to use v squared equals to u squared plus 2as. So let's write it down. So u squared is the initial vertical velocity. Okay. So that is just square root 3 over 2 times v, all things squared. And then g is minus g, so minus 2gs equals to 0. And then 2gs, we can equate it to 3 over 4 v squared. So v squared is just half gr. Okay, so the g's cancel out. So s would just be 3 over 8 times half r. Yeah, so this would just give you 3 over 16r. So this is the height, maximum height above this horizontal line that's connected to B. But they want the height above O, so you also need to add up this height as well. And to find this height, you can use your right angle triangle. So it's just R, which is the hypotenuse, cosine alpha. So add this up, over 16R with R cosine alpha. So cosine alpha, that is just half. So half R plus 3 over 16R, you would get 11 over 16R. Yep, so this is our final answer for this last part of this question, as well as the entire question. Let's head on to the next question. Okay, so for this question, we are told that two identical uniform smooth spheres A and B, each with mass m, are moving on a horizontal surface with speeds 2 and u, respectively, when they collide. Immediately before the collision, the spheres are moving in parallel to each other in opposite directions. So that means, as you can see from the diagram, the lines of the velocities, they would make the same angle with the horizontal, yeah, opposite directions, such that their direction of motion each other makes an angle theta with the line of centers. So all this is given in the diagram. And then after that, we're told as a result of the collision, B moves in a direction which is perpendicular to its initial motion, direction of motion. So that means after the collision, B, the angle here is 90 minus theta. So B moves here. I'm gonna let the velocity be VB, okay? Yeah, VB with the line of centers, okay. And then we're told that the coefficient of restitution between the spheres is E. Okay, so for the first part, we're supposed to find an expression for tangent theta in terms of E. Okay, so in order to do this question, we are first going to find like the direction that they they moved after they collided. So let's draw a diagram. So they're moving like this. So logically speaking, they are either supposed to go this way together. Okay, so like this. But then we're told that B moved perpendicular. So in this direction. Wait, okay, let me try. The heck? Oh, so it cannot make sense that A is moving in this direction. So this is the only direction that A can move, okay? So we're gonna assume A also moves in this direction. We don't know the angle here, okay? So I'm gonna just let this be W, okay? Yeah. All right. Okay, what do we now do? All right, so let's focus on B first. All right. So the first thing to note is that the vertical component of the velocities do not change before and after collision. So this is u sine theta. and this is VB sine 90 degrees minus theta. So we're going to equate these two. So VB sine 90 minus theta, that's just cosine theta. That's equals to u sine theta. Okay. So VB, let's just u sine theta over cosine theta, get u tangent theta. So this is number one equation. Okay, and after this, what else we got? Um, Coefficient of restitution. Okay, so yeah, so for that we're just gonna take the horizontal components. Okay, so for A, we have WX. So this is for A, and like that's after the collision. And then for B, okay, what should we put? We obviously just have VB cosine 90 minus theta. Okay. All right. Yeah. So coefficient of restitution, the formula for this would be relative speed of separation over relative speed of approach. Okay, so we're gonna let this direction be positive and this velocity be negative. Yeah, so we're first gonna take the speed of v. So I mean the speed of v. So VB sine theta minus WX and then over the speed of approach. So we're going to first take the speed of approach of A, all right? So for that, just take the horizontal component of this, which is just 2u cosine theta. Yeah, and then this is in the positive direction. So yeah, 2u cosine theta minus for B, that is just u cosine theta in the negative direction. So it's minus negative u cosine theta, which is just plus u cosine theta. Okay, and now 2u cosine theta plus u cosine theta is 3u cosine theta. So we get 3u cosine theta equals to VB sine theta minus WX. So this is the second equation. Okay. What else we have? Okay, yeah, this is the formula. Okay, now lastly, we're gonna make use of the the conservation of momentum. So for that, again, you just need to take the horizontal component of your velocities, only the horizontal component. So initially, we have B, so it's gonna be m times the velocity of B. Wait, no, A, sorry. So that's positive. So that is m times 2u cos theta plus, I'm just going to put a minus sign because the initial velocity is in negative direction. So that is mu cos theta. And this would be equal to, so the final velocity for B is in the positive direction. So I'm going to take that first. So that is MVB cosine 90 minus theta, which is the same as MVB sine theta. Yeah, and this would be minus M WX. Yeah. Oh my gosh. Sorry. Oh, it's still okay. All right, WX. Okay, so 2 mu cosine theta minus mu cosine theta, you get mu cosine theta equal to mvb sine theta minus mwx. Okay, now we can cancel out the m, you get this u cosine theta equals to vb sine theta minus wx. Wait, what? What the heck? All right, that is interesting. Okay. Okay, so this is equation 3. So let's take a look at equations 2 and 3. So we can see both of them have minus wx, and since we don't want that, we're gonna add those two equations up. 2 plus 3, you'll get 3 u cosine theta plus u cosine theta. That is equals to, wait, no, sorry, we're gonna subtract. Yeah, so that is minus that, you get VB sine theta. Okay, sorry everyone. I just realized my mistake. So yeah, this is supposed to be plus because this is made positive, this is negative. So positive minus minus negative, you'll get positive. Okay. Yeah. So yeah, this is positive, this positive. So yeah. Oh my gosh. How do I erase? Let me try. Okay. Okay. Good. 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 Okay, let me, okay. So yeah, we can just simply add up these two equations, 2 and 3. We would just get 3 EU cosine theta plus U cosine theta equals 2. So the WX cancel out. So we just get 2 VB sine theta. And then we can factor out the u cosine theta. You just get 3e plus 1 times cosine theta. Sorry, u cosine theta. And then vb sine theta, you can just substitute the first equation. You'll get 2u tangent theta times sine theta. Okay. Let's just leave it like this for now. So the u's cancel out. Yeah, let's just isolate the tangent theta. So tangent theta would be equal to 3e plus 1 times cosine theta over 2 sine theta. Okay. All right, now let's multiply. So cosine theta over sine theta is just 1 over tangent theta. So if you multiply tangent theta on both sides, you get tangent squared equals to 3e plus 1 over 2. And therefore, tangent theta you can write as square root 3e plus 1 over 2. Yeah, so this is our final answer for the first part. Let's head on to the next part. Okay, so now they're saying that as a result of the collision, A moves in a direction which is perpendicular to the line of centers. And so now we have to find the value of theta. Okay, so we're going to, okay, what do we do? Okay, so this angle, again, is 90 minus theta. So this would be W sine 90 minus theta. Again, which is the same as W cosine theta. So we're going to equate it with 2u sine theta. So 2u sine theta would be equal to w cosine theta. Okay. All right, let's look for an equation that is in terms of tangent theta. Okay, wait, oh, we have this, the second equation. Never mind. Yeah, wx. Yep. Okay, so we can just equate w equals to 2u tangent theta. So this is the first equation, and let's also find an expression for wx. Let's just let's see, w cosine 90 minus theta. So that's just sine theta. Okay. All right. Now, let's up everything into equation 3. So let's copy down equation 3. U cos theta equals to VB sine theta. VB sine theta minus WX. Okay? So we'll now express everything in terms of U. So VB, in our previous part, that's just U tangent theta. So U tangent theta sine theta, and WX is just W sine theta, and W is just 2 tangent theta. So WX is just 2U tangent theta sine theta. So minus 2U tangent theta sine theta. Okay. All right. So this will get U cosine theta equals to minus U tangent theta sine theta. U cancels out, so let's express everything in terms of sine theta and tangent theta. Wait a minute. What should we use? Okay, you know what? I don't think this is a good equation to use. Yeah, well, let's use another equation. Okay, let's use the one with all positive signs. So the second equation, 3EU, oh, sorry, 3EU, let me see what's cosine theta, equals to VB sine theta plus WX. So we get 3EU cosine theta equals to VB, that is, what is it? U tangent theta. So U tangent theta sine theta, and WX is just 2U tangent theta sine theta. So simplifying the right-hand side, you will get 3U tangent theta sine theta. So the 3U cancels out, and then E, you'll get tangent theta sine theta over cosine theta. So sine theta over cosine theta is tangent theta, so tangent theta minus tangent theta, you get tangent square theta. And then we can use the expression from the previous part for tangent squared, that is just 3e plus 1 over 2. So multiply both sides by 2, get 2e equals to 3e plus 1 Oh, wait, what are we doing here? Um, yeah. Okay, you know what? Let's just go ahead with the flow. Yeah, so you get 3e minus 2 equals to minus 1, and then you get e equals to minus 1. Yeah, so hence you'll get tangent theta equals to square root negative 1, but let's just write negative 1, so you get tangent theta equals to 1. So theta would just be 45 degrees. So this is a final answer for this part, as well as the entire question. Theta equals to 45 degrees. Let's head on to the final question. Okay, so for this question, we are told that the particle P is projected from a point O with speed u at angle 45 degrees above the horizontal and moves freely under gravity. So for the first part, we have to state the vertical and the horizontal components of velocity at time t. Okay, so for the horizontal component, when a particle is moving freely under gravity, um, the horizontal component doesn't change because there is no force acting on the particle, like acting horizontally, okay? So that would just be u cosine 45 degrees. Okay, so this is the particle u, and then just the horizontal 45 degrees. This is the horizontal component, which is ux. So that's just u cosine 45. So that's just square root 2 over 2 u. As for the vertical component, the initial component would just be u sine 45. But then that one will get affected because gravity is acting vertically. So it's going to, like, cause it to decelerate vertically as well. So for the expression in time t, we're going to use this formula. V equals to u plus at. So v is the final velocity. So u is the initial one. So that's just u sine 45 minus gt. That's just square root 2 over 2 u minus gt. So these are our final two answers for the first part. Let's head on to the next part. Okay, so for this part, we're told that at time big T, particle P is moving at an angle of 60 degrees below the horizontal. So for this part, we have to show that big T is this expression. Okay, so first of all, let's sketch our project out. So let's say particle P is here at time t, and the angle that it's going at, okay, the velocity, let's say it's here. So it says it's going 60 degrees below the horizontal. So if the question says below the horizontal, that means the particle has already passed the highest point, and now it's moving downwards. Okay, so yeah. So to do this question, we are going to find its a vertical component and the horizontal component. So like I said, the horizontal component is unchanged, okay? So horizontal component is still square root 2u over u, and okay, wait, oh, okay. Um, okay, so in order to make this easier, we're going to find the time taken to reach this highest point. So to do that, you take this expression and solve for t by equating it to 0 because of the highest point. the vertical velocity is 0. Okay, so you get gt equals to square root 2 over 2u, and then t is just square root 2u over 2g. Okay, and yeah, so this is the time taken. So for the time taken to get from here to here, it's just t minus square root 2 over 2u over g. So, um, okay, let me think about how we can relate this. Okay, so the vertical component, so this is 0, so 0 plus g times the t, so t minus square root 2u over 2g, you'll get tg minus square root 2 over 2u. Okay, so this is the vertical component of this. Okay, yeah. So now we are going to make use of this information, and we should also going to make use of the information that the tangent 60 would be equal to the vertical component, so vertical component over the horizontal component. So tangent 60, you just press your calculator, you'll get square root 3. This is equals to the vertical component, tg minus square root 2 over 2u over square root 2u over 2g. Wait, did I do it correctly? Oh wait, no, so sorry. Yeah, u. Okay, now we'll multiply both sides with the denominator, so you'll get square root 2 times square root 3, you get square root 6 over 2u equals to tg minus square root 2 over 2u. Okay, now you'll get tg equals to square root 6 over 2 plus square root 2 over 2 times u. You'll just get square root 6 plus square root 2 over 2u. Okay, and now divide both sides by g, you will get u over 2g times square root 6 plus square root 2. And this is the result that they want us to show, so we can write shown. Yeah, so this is our final answer for the second part. Let's head on to the next part. Okay, so now they told us at time t, the particle strikes a smooth horizontal plane at a point which is a horizontal distance d from O and a vertical distance h below O. Oh, okay. So we have to find the ratio h is to d. Okay, so let's start with the easier one, which is to find d. So d is the horizontal distance, which you take by multiplying the horizontal component, which is square root 2 over 2u times big T, which is 2 over u times u over 2g times square root 6 plus square root 2. So u cancels out. Yeah. And then you would just get square root 2 over 4g times square root 6 plus square root 2. Yeah, so this is d, all right? Yeah, now we have to find h, which is a lot harder, okay? All right, so, okay, first of all, I believe we should find the highest height reached, okay? So to do that, we're going to use v squared equals to u squared plus 2as. So u squared, that's the initial vertical velocity. Initial vertical velocity, which is square root 2 over 2. So u squared is half big U, right? Half U squared, sorry, minus 2gs equals to 0. And then you get 2gs equals to half big U squared. And then S would just be U squared over 4g. So this is the highest height that they reached. Okay, use fix U squared over 4g. All right, and now we're going to find the height that they traveled. So for that, let's see which formula is the best. Okay, since we know the time, we know the initial velocity, we're going to use S equals to ut plus half at squared. So, oh man, that's a lot of space. So S equals to ut plus half at squared. So u is the initial velocity at the top, so that's just 0, and then t, yeah, so it's just half g, and then the t is this time between here, so t minus square root 2u over 2g, t minus square root 2u over 2g squared. Okay, all right, let's see what ug is. Yeah, let's simplify this a bit more. Okay. So we have u over 2g square root 6 plus square root 2 minus square root 2. So the square root 2's cancel out, whole thing squared. You get half g square root 6u over 2g, whole thing squared. So you get half g 6 big U squared over 4g squared. So the g's cancel out. Sorry. Okay, sorry. Yeah, so this g cancels out. Okay, so this whole distance moved is this becomes 3. This 3 big U squared over 4g. Okay, and now we can find our h. So h is the 3u squared over 4g minus u squared over 4g. You would get u squared over 2g. Yep, yeah, 2u squared over 4g, that's u squared over 2g. Okay, now what should we do? So now we're gonna take h over d. So h is, u squared over 2g over d, that is square root 2 over 4g times square root 6 over square root 2. Yeah, and okay, we're going to multiply, wait, sorry. Oh my, oh, this is supposed to be u squared. Okay, sorry. Yeah, so this is u squared. Yeah, let's multiply everything by 4g, so you get uh, u squared times square root 2, so you get square root 12 plus 2. So this is gone. Okay. Yeah. So we conclude that h to d is equal to 1 is 2 square root 12. That is 2 square root 3 plus 2. Yeah. So yeah, this is the final answer for this part C. 1 is to 2 square root 3 plus 2, or you can like factorize it, make it simpler. Okay, so now let's head on to the final part. Okay, sorry everyone. Yeah, I made another calculation mistake in part C. So yeah, this is supposed to be 2u squared because 4g, yeah, 2u squared. So this ratio is supposed to be 2. This is 2 square root 3, and simplifying, you would get 1 is 2, 1 plus square 1 plus square root 3. Yeah, so this is our final answer for this part C. 1 is to 1 plus square root 3. Let's head on to the final part. Okay, so for this last part, we're told that after striking the horizontal plane, P rebounds with the speed W, and the coefficient of restitution between A and the plane is 2/3. Okay, so for the last part, we have to find W in terms of U. Okay, first of all, let's draw a diagram. So initial speed is V, and it rebounds with speed W. Okay, so first things first. In order to do this question, you have to know that the vertical component of velocity doesn't change. Okay, so let this be WY, and then this is 60 degrees because this angle is 60 degrees in here. So WY would just be V cosine 60. So cosine 60, that's half V, okay? All right. And then for WX, we're just going to use the coefficient of restitution formula, speed of separation over speed of approach. So speed of separation, we're going to let it be WX, and approach is V sine 60 equals to coefficient of restitution, that's 2/3. So 3WX equals to 2V sine 30, that is square root 3 over 2. So that, and then WX, we get square root 3 over 3V. Okay, and then for W squared, we can just get by using Pythagoras theorem, WX squared plus WY squared. So WX squared, that is 3 over 9, which is 1/3 V squared, and then WY, that is 1 over 4 V squared. So putting it into a calculator, you would get 7 over 12 V squared. Now all that's left is for us to express V squared in terms of W. Okay, so to find V squared, I'm going to take the vertical component and the horizontal component, we're going to square it. So that is 2 over 4. So 1/2 U squared plus vertical component is TG minus square root 2 over 2U. So T is UG, U2G times square root 6 plus square root 2 minus G. So the G cancels out, and then this is minus square root 2 over 2. u. Oh my God. U squared. So v squared is half u squared plus, uh, so you just get square root 6 over 2 u squared. Okay, yeah, and this is equals to square root 6 over 2 squared plus half. You get 2 u squared. So w squared is just 7 over 12 2 u squared, which is 7 over 6 u squared. So w is just square root 7 over 6 u. So this is our final answer for this last part of this question, as well as the entire question, and we have come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel for more future past paper solving videos for A-level maths and further maths. If you have any questions, queries, or doubts, or any future video ideas, please feel free to leave them down in the comments below. And I'll see you again next time. Okay, thank you.